Dear learner, welcome to today's lesson in your favorite TV channel, Hope Channel Kenya, in your favorite segment, Knowledge Quest. Our subject today is mathematics. I'll be your teacher, Mr. Mweri Sylvester. It's a continuation of the previous topic of what we learned last, that is longitudes and latitudes. We are basically trying to do more on it as we wind up the topic. But before that, we love to go back a little so that we recap on what we did. And we have a question here to help us remember what we did in the previous lesson. Now the question here is that the shortest distance between 2 points, A, that is 40 degrees north, now it's 40 degrees north, not 400. B, that is 40 degrees north and 220 degrees west, and B, that is X degrees south and 220 degrees west, on the surface of the Earth is 8,008 kilometers. So given that the radius of the Earth is 6370, determine the position of B. So it is good always to have that diagram down so you know what you're being asked. So by drawing the diagram, you also locate the points A and B, but remember to indicate the equator and the prime meridian. Then from that point, with the reference of the two, you can now draw, you can now locate A and B. A is 40 degrees north. So this is 40 degrees north and 20 degrees west. So that one right there is 20 degrees west. And B is X degrees south. X degrees south. 20 degrees west. So we should be able to locate B and A. So A is right there. Then we have B. And we are told that the shortest distance between the 2 points A and B is, so this distance here, that distance in blue is what we are given as 8,008 kilometers. Now you should first of all ask yourself, what is the distance along? Is it along a small circle or a great circle? Now because it is basically A and B, A is north of B or B south of A, then definitely it is distance along a great circle. Now it should come into your mind, how do we calculate the distance along a great circle? Distance D, maybe it's theta over 360 multiplied by 2 times 22 over 7 times R, or basically theta over 362 pi R. Now this theta, I said, or we noted the other time, that it is the latitude difference. The latitude difference. But we don't know the latitude difference because B is X degrees south and A is 40 degrees north. But that definitely tells us that this theta here, that is the latitude difference, will be the addition of X and 40. X and 40 to get that theta. But we can work that out later. Now we have the distance as 8,008 being equal to theta that we don't know over 360 multiplied by 2 by 22 over 7 multiplied by 6370. Now by correct substitution and division, we'll be able to get the value of theta. So that should be giving us 8,008 being equal to, let's use our calculator, we have 22 times 6370 divided by 360 times 7. That gives us 111.22 theta. So to get the value of theta, we'll divide both sides by 111.22 divided by 111.22. So theta is equal to what? We have 8008 divided by 111.22, which gives us 72 degrees. That gives us 72 degrees. But remember, 72 degrees is the difference in latitude between 40 degrees north and x degrees south. So to get 72, 72 is equal to x plus 40. So what is the value of x? So x will be equal to 72 minus 40, which gives us 32 degrees. But now, what is the question? Determine the position of B. Position is the same as location. Now you remember how we state the location of a place on the Earth's surface. Now remember we said that number one is latitude, then the longitude. So by writing that as a coordinate, we'll be able to write to get the answer for B. So the location for B will be latitude first, x degrees south, which is 32 degrees south, comma, then the longitude, of course, is 20 degrees west. Now, many students fail this one by first just finding 32, and they are done. So at the end, they write the position of B as 32 degrees south. So they just write it as 32 degrees south. This one is wrong because it's not giving the exact position of B. It has to be, because if you say 32 degrees south, then it can be anywhere along that latitude. But by stating the longitude, you will be able to score all the marks. Without the longitude, that one is wrong. And then number two, unless you are asked to find the value of x, just write the the position of B as that. Now I want us to move on quickly to today's concept, that is calculating speed along the Earth's surface. So just like when working out distance, speed, we also do calculate speed under this longitude and latitude. Now we're not going far from what we know, because we know speed is always distance over time, or distance covered per unit time. Same concept is being tackled here. So it's the rate of change of distance is given in 2 units, kilometers per hour or nautical miles per hour. So when talking of nautical miles per hour, that means it is nautical miles divided by hours, but this unit is known as knots. So when you see a question talking about knots, always associate knots to nautical miles per hour. And now we have an example here. We have a ship leaves Mombasa, which is 40 degrees south and 40 degrees east, and sails due east for 30 hours to point Q, which is 40 degrees south, 51 degrees east in the Indian Ocean. Now find its average speed in knots, and then B, kilometers. So number one, you also need to draw to locate those 2 points. If you do much practice, you will just do it with ease without even drawing it down. But for our case here, let's draw. So we have always the prime meridian and the equator, which are both 0 degrees south and north and east and west respectively. After that, now locate Mombasa, which is 40 degrees south, and it is 40 degrees east. So this one right there is 40 degrees east. We also have another point Q. So we have this point, at this point here we have Mombasa right there. And then we have Q at these other points, which is 51 degrees east. So this ship is sailing due east, that is from Mombasa eastwards. I mean, we're increasing. So from 40 all the way. In fact, you should know that from the prime meridian, degrees or the angles increase to the west and they also increase to the east. But when moving towards, they also decrease. Now, in this case, this distance that this ship is sailing, it is along the small circle. Now, you should be able to remember how to calculate the distance along the small circle. First of all, get the longitude difference. In this case, theta will be 51 degrees minus 40 degrees, which gives us 11 degrees. That is the angle that is between them. And then after getting the angle, remember how to calculate the distance in nautical miles. Distance in nautical miles, Roman 1. The distance in nautical miles, it will be 60 multiplied by theta, the cosine of alpha, whereby we said theta is the longitude difference and alpha is the latitude on which the 2 points are. So in this case, we will have 60 multiplied by 11, the cosine of the latitude, which is 40 degrees. By doing that, what do we get? Let's see, we have 60 multiplied by 11, the cosine of 40, which gives us 505.59 nautical miles. But that is the distance. Now we are asked to get the speed. Remember, speed is distance over time. So the speed will be 505.59 divided by the time, which is 30 hours. So 505.59 divided by 30, it gives us 16.853 knots. If you don't remember knots, you can just indicate nautical miles per hour. There's no problem. Then now we have Roman 2, which is in kilometers. In kilometers, remember to get the distance in kilometers, theta over 360 times 2 pi r, the cosine of alpha. Let me write the formula. Theta over 360 times 2 times 22 over 7 times the cosine of alpha, or rather r, the cosine of alpha. Now we're going to substitute. Let me have it done on this other side here, please. So by working out, we'll have theta, which is 11 over 360 times 22 over 7 times 2 times 6370, the cosine of the latitude, which was 40 degrees. So when you multiply that, what do you get? Let's see. We have 11 times 22 times 2 times 6370, the cosine of 40, divide 360 times 7. That gives us 937.21 kilometers. After getting the distance in kilometers, we are asked now to get the speed in kilometers per hour. So you're going to divide. So speed is 937.21 divided by 30. So what do you get? 937.21 divided by 30. That gives us 31.24 kilometers per hour. 31.24 kilometers per hour. After getting that, basically that is what you're supposed to do, because you first of all need to borrow the concept of along the small circle and along the great circle, so that you know when to apply which formula. And then after getting that, you do the correct multiplication and division to get the speed in knots or in kilometers per hour. Now the next thing that we want to look at is time and longitudes. This one I know it has been tackled in geography. Time and latitudes. Now we know that the Earth rotates on its own axis. So for it to rotate, to make one complete rotation, it takes 24 hours. And since it's 24 hours and it's a complete rotation, then that means the angle that it shall have covered will be 360 degrees. Now, if we do that conversion, if in 24 hours it covers 360 degrees, then how long does it take to rotate through 1 degree? So we convert this one to minutes. That will be 24 times 60. So if 24 hours times 60 is equal to 360 degrees, or about 1 minute. Remember, this one has been converted to minutes, the 24 times 60. 24 times 60, that gives us 1440. So that will be 1440 over 360. That gives us 4 minutes. So the Earth takes 4 minutes to rotate through an angle of 1 degree. So 1 degree basically is equal to 4 minutes. Now this difference, because places on the Earth's surface have different longitudes, we are going to use this relation here to get the different times of places on the Earth. Now you need to know that places which have different longitudes, they have different times. Like for example, the time in Kenya is very different from the time in West Africa, because we are not in the same longitude. But a country or a place on Earth that has the same longitude as we are in Kenya, they have the same time as we have, because we are in the same longitude. Now let's take an example. Let's take an example as we wind up. We have the local time of a point P that is 0 degrees 20 degrees east is 2:20 a.m. on Sunday. Find the local time at point Q, which is 0 degrees 70 degrees west. Important to note, places that are west of the prime meridian lag behind than places that are east of the prime meridian. So like for example, we have this point here. This is the equator, of course. And then we have one point. This is 20 degrees east. And this one here is 70 degrees west. And we are told that at this point P, the time is 2:20 a.m. So the time at that point P, at P, time is 2:20 a.m. on Sunday. So we are supposed to find the time at Q, and of course we need to indicate the dates. Now the first thing is get the longitude difference. Remember, the difference in longitudes gives us the time difference. So the longitude difference will be, because this is east and this one is west, we are going to add. So the longitude difference theta will be 70 plus 20. That gives us 90 degrees. These 90 degrees will give us the time difference between the two. Remember, 1 degree is equal to 4 minutes. So what is 90 degrees? How many minutes are those? So that is 90 multiplied by 4 over 1, which gives us what? 360 minutes. Convert the 360 minutes to hours. You divide by 60. Of course, that gives us 6 hours. That tells you that point P is ahead of Q by 6 hours. So what you'll do is basically you are going to subtract, because we are getting the time for Q. We are going to subtract. When moving from east to west, we subtract. If we were asked about P, we'll have added, because we know we add west to east. It's good to know that. Add west to east, then subtract east to west. When working out time differences, add west to east and subtract east to west. It's very easy. So we have 2:20 a.m. which is the same as in 24-hour clock system, that will be 0 to 20 hours. And then we are going to subtract 6 hours. Now before we get to 220 hours, we shall have gone 2 hours after midnight, of course. So before midnight, we have how many hours? Now the 6 hours, you subtract 2 hours and 20 minutes. I think 6 hours minus 2 hours and 20 minutes, you'll get what? That is 0, then 4, then 5 minus 2 is 3 hours and 40 minutes. So it is 3 hours and 40 minutes before midnight. So what time will that be? So it will be 24:00 hours, subtract 3 hours and 40 minutes. So when you subtract that, what do you get? But I want to make it an hour, that gives us 20. And then we had remained with 23 hours. So 23 minus 3 gives us 20 hours. So the time at Q is 20 hours, or basically 8:20 p.m. 8:20 p.m. So this one will help us to work out the time differences between places. Now, the reason why we do this, of course, it's for navigation purposes. So somebody will ask him or herself, how does this topic, longitudes and latitudes, help us? It can help you develop a career in marine careers. There's also piloting, being a pilot, of course, navigation in space. This one can help us to work out. So mathematics is very important as well. So don't always think of just working it out theory, because it is something that is applicable in life. Be sure to do more examples on longitudes and latitudes, because it is a very testable topic that carries up to 10 marks in the KCSE examination. Otherwise, may you have a blessed time, but be sure to work more and more examples. God bless you. Thank you. Dear students, welcome back to the lesson Longitudes and Latitudes. We were dealing with the longitudes and latitudes. Just before we ended, we were dealing with time and longitude difference as our last segment that we looked at. But I want us to look at some sample questions on what happens, on what is set in the KCSE. And now I'm taking a sample of the question, and you be keen as I read it through and work it out with you together. Now we have a question that is saying that the positions of two towns, X and Y, are given to the nearest degree as shown. So we have X, that is 45 degrees north, 10 degrees east, and Y, that is 45 degrees north, 70 degrees east. So X is 45 degrees north and 10 degrees east. Y is 45 degrees north and 70 degrees east. Now, part A, find the difference in longitude. Find the difference in longitude. Now that one is a very direct question, because we know these are the latitudes and the other one is the longitude. So basically we're going to subtract. So it is the bigger, subtract the smaller one from the bigger one. So it is 70 minus 10. That gives us 60 degrees. Then part B is saying that you calculate the distance between the two towns in kilometers. Take the radius as 6371 kilometers. This is what I was saying the other time, that when working out the radius can be given as 6370 or 6371. If it is not indicated, use the 6371. Now we're going to find the distance between X and Y in kilometers. So remember, x and y are along the same latitude. Look at that. It is north, 45 degrees north, 45 degrees north. That tells you that the distance that you're going to find between the 2 points will be a distance along a small circle. And the formula is theta over 360 times 2 pi r, the cosine of alpha. Now beware, when do we use this alpha? Is when the latitudes are the same. That is when you use the formula r, the cosine of alpha, to get the distance in kilometers. So by substituting, you have theta, which is the longitude difference, which is 60 degrees, over 360 multiplied by 2 by 22 over 7 multiplied by the radius, which is 63.71, the cosine of alpha, where alpha is the same degrees, which is 45 degrees. So when you work that out, what do you get? Let's see. So you have 60 multiplied by 360 by 2 by 22 by 63.71, the cosine of 45. Divide all that by 360 times 7. So the distance that we get here is 1000, or rather, sorry, I made a mistake. Let me redo it again. 60 times 2 times 22 over 7 times the cosine of 45 divided by 360. That should be giving us 4,719.5 kilometers. It's a very simple substitution. Then Roman 2 was saying that you calculate the distance in nautical miles. Now this one has been directed to you. It's been said that the distance, take 1 nautical mile to be 1.85 kilometers. Now once you have kilometers coming before nautical miles, mostly they tell you the relationship between nautical miles and kilometers. So basically what you're going to do is, if 1 nautical mile is equal to 1.85 kilometers, what about the distance that you obtained? What about 4,719.5 kilometers? What will it be equivalent to? So it will be 4,719.5 times 1 over 1.85. So let's see what we get. So it's 4719.5 divided by 1.85. That gives us 2,551.1 nautical miles. Very simple concept that so far you've already obtained about 6 marks, or rather 8. Then after that, the question goes on to part C, which says that you find the local time at X when the local time at Y is 2 p.m. We find the local time at X when the local time at Y is 2 p.m. So we are told that the local time at Y is 2 p.m. So we have 2 p.m. right there. So you're supposed to find the time at X when the time at Y is 2 p.m. So basically what you're going to do first is find the longitude difference, which you already have as 60 degrees. Now remember, 1 degree is equal to 4 minutes. Now 1 degree is equal to 4 minutes. And then we have the longitude difference being 60. So how many minutes are those? That will be 60 multiplied by 40 over 1, which gives us 240 minutes. Now convert that to hours. So divide by 60. That should be equal to 4 hours. But look at the question. We are asked to get the time at X when the time at Y is 2 p.m. Now, which one is to the west of the other? if you were to draw it on the globe, of course we'll have x at 10 degrees east, and then you have y at 70 degrees east. Both of them are on the same side of the prime meridian, but y is far, it's 70 degrees east. That means the time at y is ahead of that at x. So what you're going to do, because we are moving now from east to west, and I said subtract east to west. If you remember that acronym that I wrote somewhere, that subtract east to west. So basically we're going to subtract, but because this is in hours, convert this one to hours. It is 2 p.m. add 12 hours. So we get it in 24-hour clock system as 1400 hours. Then now you're going to subtract 4 hours. So by subtracting, what do you get? That gives you 1000 hours, or basically 1000 a.m. 10 a.m. That is very easy. It's very easy because you use the relation that matters is basically this one here, and always know that you subtract east to west, and also I said the other one is add west to east. This relation and this one here is enough to help you work out the equation on time difference. Now going on to example number 2, so that we see more on this topic, longitudes and latitudes. So as I read now, the question says there are a plane leaves an airport. A plane leaves an airport A. So it is A, that is at 38.5 degrees north and 37.05 degrees west, and flies due north to a point B, that is on a latitude 52 degrees. B on latitude 52 degrees north. Find the distance covered by the plane. That is part A. Now when you have a question of this kind, the first thing that you need to do is draw that diagram of the earth and locate the 2 points. And of course now there comes a statement here that says due north, sometimes due south, due west, due east. Basically what that means, it is flying northwards, southwards, eastwards, westwards, depending on the statements. But for this one it's due north, and therefore it is flying northwards from A. So we draw that diagram. Always the prime meridian and the equator should be drawn to indicate, because there are points of reference, 0 degrees, 0 degrees. And then A is on 38.5 degrees north. So that is 38.5 degrees north. And then 37.05 degrees west. So this one here is 37.05 degrees west. Then it flies due north to B, which is on a latitude 52 degrees north. Now, if the plane is flying due north, then it is not changing the longitude rather, because it is at A, this is A here, and this is B. So if it's flying from A to B, it is flying along a great circle. Due north, due south is along a great circle. But due west, due east, that is along the equator or along the small circles. Now if it's flying up A to B, that is northwards, then definitely the distance between them is along a great circle. And how do we calculate that? First of all, get the latitude difference. That is what we said, latitude difference. That means A and B are on the same longitude, because the plane is flying from A to B, which is northwards. Therefore, there is no change in longitude. What changes is the latitude only. So the latitude difference here will be 52 minus 38.5, because they are on the same side of the equator. So when you subtract that, you have 52 minus 38.5, giving us 13.5 degrees. After getting 13.5, what else do we need to do? Is to calculate the distance between them, because that is the question, the distance covered by the plane. So we have not been told whether it is in kilometers or nautical miles, but you can judge by the question that is next, because after that the plane flies due east. But let's first of all work it out in kilometers. So remember, the distance is theta over 360 times 2 pi r. So that is 13.5 over 360 multiplied by 2 by 22 over 7 multiplied by the radius. The radius we were not given, and therefore we will use 6370. So when you work that out, let's see what we get. So it's 13.5 multiplied by 2 by 22 by 6370. All that divided by 360 times 7. That gives us 1,501.5 kilometers. 1,501.5 kilometers as the distance between A and B. After getting that distance, you should be able to now to use it to get rather, we already have every information that we need. Now part B. Part B says that the plane then flies due east to a point C that is 2,400 kilometers from B. Now after the plane arrives at B, it flies due east. Now you see due east, east is always to the right, and therefore it flies due east to a point C that is 2,400 kilometers from B. So BC is 2,400 kilometers. The statement due east indicates that the plane is flying along a small circle. Definitely, we're going to use a different formula to work out that has a cosine. Now remember, the latitude along which it's flying is 52 degrees north. Now I think I can clean this one here because it's so easy, so that we create space for working out part B. Now part B is saying that the plane now flies due east from B to C at a distance. The distance between them is 2,400 kilometers. Now remember, the distance along a small circle is given as theta over 360 times 2 pi r, the cosine of alpha. So the distance is 2,400. That one is equal to theta. We don't know that angle, that difference, over 360 multiplied by 2 by 22 over 7 times the radius. We were not given, but I said we now use 6370, and the cosine of the latitude 52. So cosine 52. Now let's see what we get. So that gives us 2,400 being equal to, let's work out 2 times 22 times 6370 times the cosine of 52 divided by 360 times 7. That gives us 68.48 theta. So to get theta, we are going to divide 68.48 by 68.48. So what do we get? 2400 divided by 68.48. That gives us that theta is equal to 35.05 degrees. Now you see, the plane is flying from B to C. Now as it is flying to C, it is approaching the prime meridian. And if it is approaching the prime meridian, then that means the angle 35.05 degrees west is reducing towards the prime meridian. So for you to get the position of C, that will be, C will be, of course, the longitude for C will be 37.05 minus 35.05, which gives us 2 degrees. Of course, 0.05 is 0. But 2 degrees where? Because that will still be on the west side. So it's still west. But that will not be the position of C. The position of C will be first the latitude and then the longitude. So the position of C, to conclude, so let me just write it here. C will be 52 degrees north. And how many degrees west? 2 degrees west. So that we get now the position of C and we'll get our full marks. If we were to write only 2 degrees west, that is not correct because that will not be the position. Otherwise, the topic longitudes and latitude is very easy. That always comes in 10 marks or even 5 marks, but it is very easy to score that marks because you only need the formulas and understand the question before you do it. Now, up to that point, we conclude the topic longitudes and latitudes. But be sure to practice more on the topic so that you get to be conversant with how these questions are set. Until next time when we'll be having another lesson, may you be blessed. Thank you.